Welcome up to our videos on confidence intervals. Last video we looked at how we can use the formula to rearrange to find unknown sample means and unknown standard deviations. What we're going to do today is we're going to be working out, well, what happens to this distribution when we change the confidence interval, change the z-score, and how do we do that manually and using a graphics calculator. So I'm taking you back to this original question where we had the mangoes. And the mangoes had a z-score of 1.96. Let's just say that we wanted to increase that from 95 to 98. Well, we know that if we increase, and we go back to this one here, this was approximately 229 mean, that's to 242. So that gave us an approximate distribution of about 13. If I increase the width, now thinking about this in your head, if you increase in the width, again, coming back to the normal distribution curve, if this here is 95, this here is 98, what's happening to the width of your distribution? Well, what you would expect it to be is you expect it to increase. But how do we make those changes in the graphics calculator, and how do we get the z-scores so we can run into a formula? So let's do that right now. So if we want to work out the new width using a different percentage, well, that's not difficult at all. We just come back to your calculator, okay, we come back up here, and we'll change this to 0.98. 0.98. We then put our deviation here, I think it was 24.5. Our was 236, and we had 50. So if we come back down here, what you will notice is we will get 227, and we'll round it. So 227 is less than equal to the mean, which is less than equal to 244, which is slightly larger. So we increased by 4. So it's approximately 17 here. And that's what we expected from looking at that diagram. If we're increasing the confidence interval, we're increasing the width, so therefore we're increasing our values for our lower end away from the mean. But if we want to find a formula, so for instance, just say we wanted to find out what would the z-score be for the 98%. Remembering, when we look back at your z-score, and we look back at your z-score in terms of the curve, we have 0, 1, 2, 3, -1, -2, and -3, where here is your mean, and the distance between each of these is the deviation. So that means when you're working out a z-score, the mean is always going to be 0, and your standard deviation is always going to be 1. However, when we're working out with confidence intervals, what you will notice is that we have 2 of these. So to find your z-score, we have to go all the way back to inverse norm. So let's go back into your calculator, go to 2, we're going to go distribution, norm, inverse norm, and this is where we start changing this data up here now. Instead of having a tail that's right, we want a tail that's center. So if we come down here, we click center, and what that's going to do is that's going to give me a positive negative answer, because I'm going to have values that represent that z-score in 2 different points. Area, well, this time we want 0.98. Okay, so we're going down here, 0.98. Your deviation is going to be 1, your mean is going to be 0, and then if we press enter, what we are expecting, now if you think about the graph here again, this is where 1.95 was, that's about 95. 98 a little bit further over. So we would expect our z-scores to be greater than this. So if we click enter here, that's what exactly we get. We end up getting positive negative 2.33. And that's how you calculate your z-scores. You need to use the inverse norm, and then we can come back here and replace 1.96 with 2.33 for a confidence interval of 95%. if I wanted something that was less than 95, just say 90. Well, 95 sits here, 90 should be less than 95. So again, we come back, we go exit. This time let's go back up and just change it to 0.9. You will find that it has reduced. It's now negative 1.6 and positive 1.6. Really important to understand how to change the Z-score on your calculator and how to do it manually. Because there are always going to be questions where it says, calculate the Z-score of this data distribution at 98 or 95 or 96 or whatever percentage. Okay, good luck and I'll see you next one.